Welcome to my new calculus channel. I am John Gabriel. In this video we discuss the Riemann definition of integral used in the standard calculus. So, the Riemann integral suffers from more or less the same kind of problems that the Cauchy derivative suffers from. For example, in order to find the area under the curve, one needs to know the limit, and I'll explain in a minute how that works. But let's just see what happens here as we move the slider towards something that resembles infinity. We keep on getting closer to a value of 4. Now, if we want to make the absolute distance in our E delta argument between the sum and the limit as small as we please, we need to know the limit. So if, for example, the limit is not a rational number, then we have no way of identifying it unless we recognize it as one of the well-known irrational numbers, such as pi, square root 2, or something else. So in fact, the limit definition is actually faulty for the very same reasons as the Cauchy derivative definition. So let's look at the notes quickly. These are the summary. These notes are the summary. One is informed that the sum is that number, which is approached as n gets closer to infinity or approaches infinity. And as n gets closer to infinity, the sum is always an approximation. So one must at some stage reach a stopping condition. Now, as I said earlier, the difference between the sum and the limit L needs to be less than some epsilon. You have to guess what L is. Guess? Yeah, that's right, because in most cases no irrational number has a finite representation of any sort. And as I mentioned earlier, the only exceptions are the well-known incommensurable magnitudes such as pi, e, square root 2, etc., that have a recognizable approximation. So if L is not a rational number, then you can't show anything about the difference between S and L, and you can't make it as small as you wish. So, in fact, the problem here goes way back to George Cantor, and the irony is that if we have to follow what George Cantor developed as his main ideas and thoughts about infinity, we'll always end up with the same kind of problem. And we have, again, the same ill-defined limit concept, which is similar to a dog chasing its tail. So really, what we have here is the same problem as we do in the Cauchy derivative definition. Yeah? Okay. Well, that's all I wanted to show you in the Riemann Kludge. It's probably not the best example, but it really is representative of the problems that one finds when trying to make sense out of a definition framed in terms of the limit. This is a new calculus channel, and I'm John Gabriel. Glad you could join me. Hope you'll join me again next time. Thank you.